give you an idea a little bit in this discussion, we're talking about failure mode and effects analysis and simplified risk analysis, and how these can be a blessing to a GMP auditor's soul and to you if you're audited and if you have actual data that you can present relative to a formal FMEA, because what that shows is that you've gone through exercises relative to risk analysis and taken a critical look at your process to determine and mitigate the risks that are present. We're going to talk about actually using FMEA in application to processes within the cannabis industry, and how implementing these and following through with the mitigation steps can put you in a really terrific position to excel and minimize safety risks to your consumers and have it documented. And as you know, the cannabis industry is evolving continuously, and depending on if you're looking at it from a perspective of a state or a perspective of the federal government, or if you're in a different country and you're looking at it from provisional perspectives or national perspectives, there's certainly many different ways and approaches that allow the operation of the industry within those authorities having jurisdiction. And right now in the United States, we see, certainly the regulation of cannabis, at least within a state level, we see FDA, CFR 111, CFR 21-117, for food safety and dietary supplements becoming incorporated in many of the state guidelines. And of course, with the world here in the United States, kind of wrapping themselves around, well, the 0.3 weight percent THC level, the legal aspects can get rather tangled because we're talking about the same plant. And so it goes. But when we're looking at FDA regulations, let's think about food safety, let's think about dietary supplement safety. It's within those constraints that this talk is looking at specifically. We have the world of industrial hemp. I'm not going to go into that because many of those products are not necessarily for direct human consumption, like food in their mouths or essences in their bodies, more construction oriented and fabric oriented, and that. We're not going to go into that. What we're interested in is what human beings or animals may put in their bodies: vaping, smoking, tinctures, cosmetics, food additives. Some people call nutraceuticals, which is kind of funny, but I won't go into that. Pharmaceutical incipients. And essentially, these guidelines are based on risk assessment and risk mitigation. And certainly within 21 CFR 117, HACCP is often applied. That's hazard analysis critical control point. And these are systems that are specifically designed to alleviate and mitigate any potential health risks to consumers. And HACCP is very stringently applied in many different food industries, from meats to dairy to nuts to really anything people are putting in their mouth, even in the sucrose industry at the sugar refineries. They definitely follow a HACCP protocol, identifying the major hazards associated with human consumption. And one of the first steps relative to risk mitigation is to do a risk analysis. And what I'm talking about there, is formal exercises that can be implemented that really characterize what the risks are and how can we mitigate them. And I'm going to take it from an example in the cannabis industry. And within the framework of that, certainly there are a lot of risks associated with cannabis. And now I'm talking more general. It may be about CBD high cannabis or THC high cannabis at any rate, whether on a state level or on a federal level in the United States. There's certain elements that need to be answered and certain risk protocol that need to be implemented. And part of that, at least with regard to the FDA guidelines 117 and 111, we're talking about sanitation procedures. Certainly, how do you maintain your sanitation? Normally, that would occur through environmental control of your facility. What is your equipment? How does your facility operate? What are the process specific procedures? Are there things being done in a process that may incur risk or something that could be alleviated or mitigated? And of course, maintenance is a critical element. Your quality control procedures, well, they define your quality management system and really drive that train. So that's an important element. And of course, pest control is another element associated with that. But what I'm gonna kind of drill in, and I'm really giving more an example of how can we apply a specific risk assessment. And we talk about facilities and facility design and process flow. It's within this framework that many opportunities to mitigate and recognize possible risks. I should say that backwards. I did say it backwards. To recognize and then mitigate potential risks. And I'm going to go through some steps on some things that we would do with a client as we were helping them implement FDA approved GMP facility or European Union GMP approved facility. And there's several things we look at. And the first thing we do, let's look at the whole 25,000 foot view. Personnel flow, raw material product flow, waste flow, equipment flow, and then whatever environmental control aspects are existent within that facility that promote those other elements. And here's an example of a fictitious facility. And this particular facility takes in raw cannabis biomass. It's expected that this is CBD type biomass, so it's less than 0.3 weight percent THC. And that biomass is loaded into baskets, and those baskets are then solvated and treated in various extraction and distillation processes to extract a final tincture, oil, crude, whatever the objective of the facility is. And within that, ultimately, these products will be destined for food consumption. In this case, they'll be going into gummies and juices, and thereby directly fall under 21 CFR 117 and be accountable to those guidelines. So this is the steps bringing us to that level of accountability. And I'm just sharing that. We're going to take it, what we do as we do the analysis is we look at every aspect, and we're interested where staff goes and what the flow is, and do we have adequate protection? Do we have airlocks if necessary? Many situations don't require that, but we look at that. And so we define GMP areas as GMP1 or GMP2, with GMP1 being kind of a lesser sanitation area and GMP2 being quite regimented. And you can see in this diagram, we're looking at pressure differentials in these different areas. This is a GMP area. We have a high partial pressure, which essentially makes a general airflow outside of the area. Here we have still a positive pressure, but not as positive as here. So it's not pushing into here, but it's pushing out to the other areas. And we try to balance that with actual material flow, which is represented by the black areas. personnel flow by the red and blue areas relative to the level of protection required, whether it's a GMP 2 or GMP 1 area. And then the other areas, and really just try to understand that. And as we put the package together, as we look at the total facility design relative to maximum sanitation, we'll go into each area in each different room, and we'll actually do an FMEA for receiving and a QC lab and biomass storage, and each one will have its own FMEA, which is failure mode and effects analysis. And right now, I'm going to take you through that step, though we're looking at material preparation, in particular the basket loading areas. So we have kind of a grid and an outline. Now, the cool thing about FMEA is you have a group of people as subject matter experts in the room, and you, in a rather general way, characterize the risk elements associated with each risk and really try to come up with those and categorize those. So, and I'm only going to be glossing the surface of it. Any particular area could have many, many risks, and frankly, this could be, a rather extreme exercise. But at the end of the day, you're going to know what you need to do to make your facility perfect. And once you provide the data and you do the implementation, your GMP auditors will be quite pleased and quite impressed, because this is the basis of all those guidelines, risk analysis. So in this case, we're looking at, we got a process step here. We're bringing super sacks into the loading area. We have to place it somewhere. We have to weigh it. And we have some administrative aspects relative to characterizing that product. So what could go wrong when we ask that question? Well, in this step, certainly there could be some compromising of the product, the bag penetrated material falling out. Relative to weighing, there could be a scale out of calibration. If we don't get the bulk density value properly, that could propagate down the line in batch calculations and end up with a mix that is not desirable and falls outside of the final user requirement specifications. So we look at some different actual failure modes and what could happen, or what happens if this failure occurs. And so we're looking at several things here. In this case, we're looking at cross-contamination. We're looking at, erroneous weights, which are going to affect all downstream processing where calculation may be involved. You may end up with something different than what you desire relative to your user requirement specifications. Various causes are looked at, and what situations are in place to actually detect when these occur. And so these are the three things for the effect. We look at, well, how severe is the effect? And normally we'll rate those on a 1 to 10 scale, with 1 being, well, it's really not that big a deal, and 10 being, well, the customer might die if we fail here. And that would be introducing, toxic bugs, or not, introducing aflatoxins or heavy metals or what have you. Anyway, we characterize the severity of that risk in the first column. And in this case, we have a 6, a 5, and a 5. Then we ask ourselves, well, what's the frequency of occurrence? How often might this happen? And again, these are inputs from the subject matter experts sitting around the table, and this is a brainstorming exercise. And it's concluded, on a scale of 1 to 10, the idea of, say, a super sack being compromised and its contents spilling out, they give that a 3 for occurrence. Now, there are tables that help you define exactly what those mean, and oftentimes they are segregated into tables that speak of part per million defects, or how often does this happen, or for example, does this happen once a week, or once a day, or once a shift, or once every 2 months, and that kind of general feeling will drive the approximate sort of guideline of frequency of occurrence. And then the next series of reflections are going to go to, well, are there processes in place to detect if there's going to be a problem here? And these would be quality control related processes. These would be work instructional operators instructed to perform in certain capacities if a visual confirmation of some compromised activity is seen to occur. And so the ability to detect it then obviously is going to play a role in the mitigating of it. And so with a common FMEA, we'll take all three of those values, we'll multiply them together, and notice we have for what we call our risk priority number. For the first row, we have 18. For the second, we have 150. And the last, we have 120. What that means is the risk that's 150 and 120 are far more severe than the risks associated with the 18. And that's good to know. And that starts to basically provide us a list of priorities of what we really need to deal with. So we look at those risks and we say, well, what can we do to fix that? And if we were to fix that, how would those numbers change? And so the tail end of that analysis, then looking at each, and the first column here, I have the original risk priority numbers of 18, 150, and 120. And we follow through and we have a discussion and we figure out basically what we need to do to mitigate those, and then reassign, if mitigated, what those numbers would be. And then you can see the final column there. We've reduced the risk priority numbers from 9 to 40 to 5, which are pretty significant reductions. And these will come through the implementation. Now, this is not a complete FMEA here. And note that there is a column called responsibility. And it's within these discussions that we assign responsibility in specific tasks. If we need to write more SOPs, if we need to implement some additional equipment, what have you, all of those would be articulated within this column that's currently blank. And thus we have our failure mode and effects analysis. And the cool thing about it is we can go ahead and build a Pareto chart on what we call pre-RPN and post-RPN. And the pre-RPN would be pre-risk priority number. So you can clearly see what the issues are within that part of the process we've just looked at. And sanitation, scale calibration, shake out to be some of the heavy hitters, and so forth down the line. And then the red bars indicate how those risk priority numbers change through whatever implementive processes we determined for mitigating those risks. So it creates really kind of a guidepost of how we want to proceed. And another cool thing about this is normally with the FMEA, we're going to look at the top 5 heavy hitters and probably deal with those, and then go look at the other ones, because those are the ones that are going to be the top 5 are going to be the higher risk areas and higher risk opportunities for improvement. We go look at, take the post RPN numbers. These are the numbers after applying whatever mitigation steps were suggested in the exercise, and then looking at those as a Pareto. Basically, every single one of these are opportunities for improvement. And if you're an organization that values that idea of continuous improvement, these type of exercise can become the wish lists of things that you might want to implement or look at or define a project around moving down the road. And each of these would be a rather significant change for the better for the safety of your product to your consumers. And so it's a great way to generate continuous improvement project data, if that's something that you're interested in. So anyway, what I focused on right now is take a look at your facility design, draft it up, do a process flow map, and then look at each little part and ask yourself what could go wrong, what could go wrong. And there might be 100 things that could go wrong. Well, if they do, how often will they go wrong? What's the severity of the situation if they do? And then what practices do we have in place to detect them? And then assign numerological values to that, generate your RPNs, and you have a rather quick method that you can pull expertise from your entire team and really kind of define what exactly you need to do to assure that your product is completely safe for consumer production. And it's very powerful. And I believe that it's one of the few approaches that you can use to really get down to the brass tacks of what's going on in your process. And relative to those who are in food safety, recognize that the HACCP program is basically a failure mode and effects analysis, modified just a little bit. I like this particular approach because I feel it gets a little deeper into the weeds and the rabbit holes that we need to without necessarily wasting a lot of time. So you find opportunities for change, for mitigating risks. You do implementations. Those implementations then are articulated in modifications to SOPs, which are then communicated back through the process through whatever change control system you have set up. And basically there you go. And the cool thing is when you go through this exercise, you have the data from the original assessment, and you have the Pareto chart showing primary areas of risk and lesser significant areas of risk. But you also have the steps that were put into place to deal with those. And by the time that auditor comes around, hopefully you have data that shows exactly how effective that risk mitigation event performed. And these kind of exercises, when you go through them and you maintain the documentation, they can become a focal point of a lot of the auditing process and really help the auditor understand the extent and nature of how you implement your QMS and how it truly is a risk-based system. And anyway, with that, I know it was a quick presentation. I wanted to just cover just a very general overview of it as best I could. And I hope you found some value in it, and feel free to reach out and send comments or what have you. Or if you want to learn more, please feel free to reach out to me and we can chat. Anyway, thank you for your time and enjoy your day.